Hello friends, welcome to your video from chapter 3. This is a quick review of what we did in class since you have a week of break so that you will be able to remember. So if you can, please watch this before you come to class. So either Sunday or Monday, the day after you come back on the 22nd, watch it so you will remember what we did. 3.1, one-step equations, and that's when we just learn how to do equations. I have 4 columns because we're going to go through all 4 operations at once. But I wanted you to remember that in order to solve a one-step equation, all you have to do is do the opposite of the operation that's given to you. So we're going to start with this one. X plus 7 equals 4. I need to do the opposite of plus, which is minus, and I need to get rid of that 7. What I do on one side of the equal, I do on the other side of the equal. Why do I do it here? Because I have an x. 7 minus 7 goes away. 4 minus 7, very important, negative 3. Please remember your signs. And we're done. We just did the opposite of what we had there. Let's move on to the next example. X minus 12 equals 3. If I have a minus there, I'm going to do a plus 12, a plus 12. I'm doing the opposite of whatever is given to me. This goes away. X equals 3 plus 12, 15. Let's move into, we did addition, which the opposite was subtraction. When we did subtraction, the opposite was addition. If we don't have anything in there, please remember, that means it's a multiplication. If I want to do the opposite of multiplication, if you remember we said this in class, it's division. I'm going to divide by whatever is in front of that x, which is negative 6. Please don't divide by x. You need x alone. We just get rid of the number in front of x. What we do on one side, we do on the other. Negative 6 divided by negative 6 gives me 1. That's the reason we're doing it. It's gone. X equals 48 divided by negative 6. A positive divided by a negative. 48 divided by 6, 8. And then the last one is this little fraction here, which we said that fraction represents division. The opposite of division is multiplication. I encourage you always to put it on the top. Don't put it on the bottom. Please don't put it on the bottom. You're going to confuse yourself. Times 4 times 4. The reason we do this is because now this reduces with this. X equals 5 times 4, which is 20. So as we solve a one-step equation, we want to pay attention with the operation we start and do the exact opposite in order to get rid of whatever is on this side and move it on the other side so we can find our x, okay? The only other different problem that we worked in here, and I'm going to go ahead and erase this really fast so I can make myself some room, is when we sometimes have to times by the reciprocal, and that problem looked like this. Negative 2 over 7x equals 4. Again, remember this is a multiplication. And really, in order to work this correctly, the opposite of the multiplication would be division, right? So I would have to say divide by negative 2 over 7, and then divide by negative 2 over 7. Who wants to do a fraction divided by a fraction? Nobody, right? So we said instead of doing that and confusing ourselves, the other way to do it, and you've learned this back when we learned multiplication of fractions, is we times it by its reciprocal. The sign stays, and then the reciprocal is 7 over 2. Negative 7 over 2. We just times it by the reciprocal. Why? 2 goes to 2, 7 goes to 7, and negative times a negative is a positive. All of this is gone. I have x equals, and there's 2 ways to do this. You either multiply across, and then you reduce, or you can go 2 into 2 once, 2 into 4 twice, 2 times negative 7, negative 14, because it's a positive times a negative. And we solved it like this. So this is mainly what we did in class. Opposite operation, unless you have a fraction, in which case you just multiply by the reciprocal, which really goes back to, if you've learned this way, to copy, switch, flip. When we divide 2 fractions, we copy the first, we switch the sign, which means we multiply, and then we flip the second fraction. And that was basically what we did in 3.1, and we're going to move on to 3.2. Two-step equations is what we learned in 3.2, and we're going to go through all of the examples that we did in class, just a quick review. The first one is x over 2 plus 5 equals 11. And we said as we move to two-step equations, we first want to move everything that does not have x on the other side by, again, doing the exact opposite operation. This is minus 5, minus 5. Then we end up with x over 2 equals, that's gone, 11 minus 5 is 6. Now we're back to one-step equation. That's a division. The opposite of that division is multiplication by whatever we divide. So by 2 in this case. This goes with this. X equals 12. They reduce, so you end up with x equals 12. And I told you in the book, they say check your answer. You don't necessarily have to check your answer ever unless you really choose to. But if I would need to, look at this. 12 divided by 2, 6, plus 5 is 11. It does work out. Let's look at the next type of problem. And this is more of a combine. I have 7 apples and I take away 4 apples, or x's. Then I end up with just 3 apples equals 12. Well, this is a multiplication. The opposite of multiplication is division. 3 divided by 3 reduces. X equals 12 divided by 3, which is 4. This was an easy one because this is just, you have a number of something and you take away the other number. 7 minus 4 gives me 3 of that x's, and then I solve that. This is the one that gave you the more problem, this type of problem. So we're going to work it again, and I have 2 colors. I'm not sure if they're going to show up in the video or not, but I have a red and I have a green, and I'm going to use them to remind you what's what, because we have some keywords. The output, as soon as you think output, please think y, of a function is 3 less. I'm going to use green for this one and tell you that means subtraction. 3 less means subtraction. Then 5 times, that means multiplication, right? And the input we learned in chapter 1, that is x. Find the input or find x when the output or when y is 17. So let's go ahead and write this equation the right way. It says the output y of a function is, that means equal. 3 less, we said, is subtraction, and times is multiplication. The order of operations says multiplication comes before subtraction. 5 times the input, which is x, and then it's 3 less, minus 3. Okay, the output is 3 less than 5 times the input, which is x. That's how this works out. Now I'm going to go ahead and it says, find the input, find what x is, when the output, when y is 17, which means instead of that, I'm going to have 17 equals 5 times x. I'm sorry, I'm using 25 colors here. I need red. Minus 3. Look at me. Well, it's just a regular problem now. I'm going to have to go ahead and plus the 3 on both sides to get rid of the 3. I have 20 equals 5x. Then I need to divide the 5 out to do the opposite of the multiplication. X equals 4. And we found the input when the output is 17. X equals 4. These are the type of problems we worked in 3.2. And I think the most problem that you had here was getting it from the word looking to this. So I'm hoping maybe this all colorful thing helped you a little bit. I don't know, but maybe. We'll try again in class next time. I'm going to go ahead and move on 3.3. 3.3 dealt with multi-step equations. So we did one-step equation, two-step equation. Now we have a lot more going on. And so we're going to go ahead and dive in immediately and see how we solve this. This one is an easy one. The first thing we want to do is go ahead and combine the like terms. I have 8 apples. I'm taking away 3 apples. I'm left with 5 apples. Minus 10 equals 20. And we're back to a two-step equation. I move my 10 over first. I end up with 5x. This is gone, equals 30. I divide the 5 out in both places to do the opposite of that multiplication, right? X equals 6. So We combine alike terms first. We got rid of the 10 to move it on the other side because 10 did not have an x. And then we divided the number in front of x because that was a multiplication. This is the one that dealt with distribution. And we said when you have a distribution, the first thing you're going to do is always going to be the distribution. Please remember two things. We distribute that 2 in both places. We do not add, we multiply every single time. So this becomes 7x plus 2x. 2 times x is x, plus, because a positive times a positive is a positive, 2 times 6, 12, equals 39. I'm now back to here, basically. I have 2 alike terms. You see them? 7 apples, and then I have 2 more apples. That gives me 9 apples plus 12 equals 39. And I am back to the two-step equation. Minus 12, I need to move the 12 on the other side. 9x equals 27. And then the last step is divide this 9 out because I need to get rid of it, which means x equals 3. And if you're going to look in your book, you're going to see that they continuously go ahead and check their solutions. You don't have to unless you're very, very unsure of yourself. You should know that for your homework, for most parts, I want to say about 95% of the time, you're going to give a whole number. If by any chance you get a fraction, stop and go and check because chances are you're not supposed to have a fraction. The last type of problem that we worked in here was one that has in front of it a fraction, which takes us back to the two-step equation when we said that when we have something like this, instead of dividing it a fraction by a fraction, we're going to times in both places by its reciprocal. The reciprocal of 3 over 2 is 2 over 3. If that would have been a negative 3 over 2, the reciprocal would have been a negative 2 over 3. The sign stays with it. The reason we do this is because this goes with this goes with this. So we're done here. 3x plus 5 equals. There's 2 ways to do it. You can multiply across, which means you can put this over a 1 and end up with negative 48 divided by 3. Or you can just go, 3 goes into 3, 1. 3 goes into 24 8 times. Negative 8 times 2, negative 16. We are back to two-step equation. Minus 5, minus 5. 3x equals negative 21. Please remember, negative 16 minus 5. I owe $16 and I borrow 5 more. How much do I owe now? Negative 21, right? Then I divide by 3. Oh, this is supposed to be red. Sorry. I divide by 3. That's the opposite operation of the multiplication there. That goes away. X equals negative 7. And this is how we did when we did the multi-step equations, which means either we first had to combine, then move over, then divide, or we had to do the distribution first, then combine, or remember, every time you only have a fraction in front of here and it's a multiplication, you can just go ahead and times by its reciprocal and get rid of it, okay? And that was 3.3, which takes us to just 3.4. That was maybe a little bit difficult because it had both x's on both sides, but we'll work on it in a second. Okay, 3.4, not 3.3. This is the part where we had variables in both sides of the equal sign. So let's go ahead and remember how we did this. We said that the first goal that we have is bring all of the x's on one side and all of the numbers that don't have x on the other side. And I told you in class, I really like working with positive numbers. So in my way of solving it, I'm going to go ahead and the first thing I'm going to do is I'm going to move my 8x over by doing the opposite, which is addition. Again, I like positive numbers. That's how I work. So this becomes like this. This gives me 12x minus 17. On this side, I am only left with a 7, right? Now I need to move the 17 because it does not contain an x to the other side. This is a two-step equation, right back to where we started. Plus 17, plus 17. I should have drawn the line with the black, but I didn't. That goes away. 12x equals 7 plus 17, 24. And look how beautiful positive numbers I have. The last thing I need to do is get rid of this 12 to only have x alone there by dividing the 12 out, which tells me x equals 2. So really, it doesn't matter. If you would have done it the other way around, as in if you would have minus the 4 and minus the 7, you would have gotten the exact same result. I just don't like working with negative numbers unless I really, really, really have to. And in this case, I didn't have to. So all I had to do was move and work positively so I don't ever have to worry about signs, remembering what kind of division, if I get a negative or a positive and stuff like that. The second example that you had in your book was 9x minus 5 equals 1/4 16x plus 60. And to be honest with you, I would have never solved this the way they did in the book. I would have gone ahead and times this by 4. But we're going to solve it the way they did in the book, which means they distributed this here. Please remember, we distribute on both places. And please remember, we always multiply. We never add, okay? 9x minus 5 equals 1/4 of 16 is 4. So that's 4x. If you ever struggle with this, just put in a calculator. Do 1 divided by 4 times 16. See what you get. And then you go 1 divided by 4 times 60. Just in your calculator, see what you get and get your answers out, okay? And then 1/4 of 60 is 15. And now I have to bring all the x's together. I like working positive. I'm going to move the 4 on the other side. Because it doesn't have a sign in front of it, that tells me that's a positive 4. I'm going to minus it. (5x minus 5) equals 15. And now I'm going to go ahead and move my 5 on the other side. Plus 5 plus 5. That goes away. 5x equals 20. The last step is dividing that 5 out, which tells me x equals 4. Right? So what did we do first? We did the distribution. And then we went ahead and brought all of the x's on one side, all of the numbers that don't have x on the other side. And then we went ahead and finished it by doing the opposite operation at the end and getting our answer out. The only other thing that we had in this chapter that was pretty funny and interesting was the two types of equations that are not just an x equals something. We said that there's options when you will have no solution. And then there's going to be options when we have an infinite of solutions. So let's look at the two of them. We have 3x equals 3 parentheses x plus 4. This is our first type. And the second type is going to be 2x plus 10 equals 2 parentheses x plus 5. And we're going to try and solve these two together. Let's go ahead. We said the first thing we always do when we have a distribution is we do the distribution. We always multiply. We never add. 3x equals 3x plus 12. By this point, your eyebrow should almost go up going, But let's go ahead and do what we know what we need to do, which means bring all the x on one side. Minus 3x minus 3x. Well, 3x minus 3x gives me a 0 equals 0 plus 12, which means 0 equals 12. Never. Which means in this case, 0 never equals 12. We have no solution. There's no x that will satisfy that equation. There's no solution. Let's look at the next one. Again, we have a distribution. We'll do the distribution first. 2x plus 10 equals 2x plus 10. Look at that beautiful number. First things first. I'm going to bring the two x's on the other side to have x's together. This becomes a 0 plus 10 equals a 0 plus 10, or 10 equals 10. Always, no matter what number I put in there, 10 will always equals 10, which means I have an infinite solution. I can't spell. I have infinite solutions. They call it in your book, they call it all real numbers. It's an identity. You can tell me all real numbers, infinite solutions, identity, whatever you want to call it, it's the same for me. So remember, there are two options. Sometimes you will not have any solution, and I have assigned you homework that has no solution, just on purpose. How do you get there? You get to something funky like 3 equals 5. Then you have a problem, right? Or you have infinite solution, and that is when 3 equals 3 and 5 equals 5 and 9 equals 9. You end up with something that it's always true, which means no matter what number I plug in here, there would be a solution to that equation. And that's about all we did. On page 156, right on the bottom, you have a really nice summary that I would encourage you to read because it tells you exactly how to solve step by step each type of equation. And it will help you on your homework. And I hope this video helps you on your homework. We kept it at 20 minutes. I'll see you next week.